mercy. Guys, if you can see the feed on Facebook, if you can let me know, that would be fantastic. If you can see.
So what?
Okay. Just go back.
I'll join Discord chat. Also, YouTube. Where do you find? Okay.
I'm hoping it's not something to do with Restream. Live, okay. All right. Sup. It's just starting right now. Awesome.
Huh?
Okay. It's. We should be back up live now. Should be.
Oh.
Okay. We're doing 20 seconds, frames a second. How are we doing? Excellent frames. All right, we should be back up. We're doing 20. It's working. Oh, cool. Awesome. All right, so that's weird. So I've gone down to 20 frames per second. And that was really weird because we had no drop frames before. Twitch is running well. Awesome. Thanks, Numbat. Thanks, guys, for letting us know. So hopefully we'll get through this without our webcams, and then we'll always have a play around with it later on. Okay. So what we'll do. So hopefully, damn it. So what we'll do is we'll go back and we'll redo. We'll talk again about the it's butterfly cluster. We do apologise for this interruption, guys. It's always a little bit annoying when technology gets in the way of things. Okay, let's get back. Let's get busy. All right, thank you very much, guys. Awesome, and yeah, great that it's Stellarium that's showing now. It's awesome. All right, well at least we know that it's working across Facebook, Twitch, and also Periscope as well. All right, guys. So sorry about that. We'll get started again. So this is this butterfly cluster. It's an open star cluster, which is very, very young stars. These stars are only about 100 million years old, and they consist of about 80 stars, and it's about 12 by 25 light years across. Most of the stars, as you can see, have a bit of color, this bluish color, and they're very, very hot stars. And when they're very big and they're big blue stars, they live hard, they die young. So just like the 27 Club, John, they live hard, they die young. So and they're all formed from the same molecular cloud as well. And so this was discovered by Giovanni Hodinara in before 1655, but his data wasn't actually found until 1980s. But Robert Burnham, who actually named the butterfly cluster, he actually proposed that probably the first century astronomer Ptolemy would have seen it as a naked eye object when observing its neighbor star cluster called it's Ptolemy's cluster, or M7. And it was also independently discovered by Philip de Chiese, and in 1745 to 46 as well. And if we go back to Stellarium, we can see that it's right above us at the moment. So this is the view from the Perth Observatory, and right above us up here, in the tail of the Scorpion, just off from the Stinger, is Ptolemy's cluster, right? Is butterfly cluster. But we're going to go to next is actually Ptolemy's cluster, which is also pretty cool. And so, John,
Yes, Matt.
how far away is this star cluster?
Well, the current estimate's about 1,000 light years away. So you think in this day and age of super precise measurements of gravitational waves, you think they'd know these things to the nearest centimetre, but it does take a bit. It's still a bit tricky to measure the exact distance. So, but the latest measurement suggests it's about 1,000 light years away from us. Yeah.
Okay, guys, sorry about that. We got some new people. So, and we've just had to turn off our webcams just to make sure it's working. So, Carlos, my name is Matt. This disembodied voice, and this disembodied voice, which you're about to hear, is John Ford. John, say hello to Carlos.
Good evening, Carlos. Welcome to the Perth Observatory.
So guys, if you're just watching again, it's cloudy night here, so we can't actually see through the telescopes tonight. So what we've done is we've prepared some images through the telescope you would have been having a look through. So you don't miss out. We still get to show you some cool stuff in the night sky. And if you do have any questions, if you're on Facebook, please send them through. And we get the feed here as well, and we've also got a Discord channel for people who are as well, and they'll appear up on the bottom left of our the feed here as well. Unfortunately, we had some technical issues with the frame rates, and that's why it was buffering, so we had to turn off and turn it back on again. So, all right, so this is what the actual Ptolemy's cluster looks like. It's really more of and we've also got Alicia saying hi, Carlos, as well. Ptolemy's cluster is actually probably better to look through binoculars. It does take up quite a lot of view through the telescope. So if you're choosing one or the other, the butterfly cluster would look better in the telescope, but a binocular or a wide field telescope like a refractor, like a ED80 telescope or something like that. This would look nice in here. And actually, I've taken this image of both the butterfly and the Ptolemy's cluster through the ED80. That's on the Meade 14 telescope. So we're not in the big tank today. So this star cluster is actually bigger than the butterfly cluster. This is about 50 light years across. It's closer to us. The actual tidal radius of Ptolemy's cluster is about 40 light years away from us. So the stars in here can't actually pull themselves away from the cluster, and that's by the gravitational influence of the Milky Way. So anything outside that 10 light years, it's the 5 on either side, they can be ripped away from the Milky Way. But to get kicked out of the bunch within that 40 light years in the center, you have to be kicked out by getting too close to one of the other stars, and that will happen over the next couple of 100 million years. And two of those 80 stars, this cluster actually has about the mass of about 735 times that of the sun. So imagine having 735 suns on your foot. You'd be really, really wanting to, that would be very hot. So John Donner is actually asking, how do you define the outer edges of a cluster?
Oh, that's a good question. I know it's a tough one. It's like with globular clusters, trying to define what's the edge of them. I can't answer that off the top of my head.
You'd have to really do it through spectral analysis. because a lot of these stars are actually, because they all form together, when we do a spectral analysis, and that's where we send the light through a prism and split out the light into a rainbow. And out of that, what happens is you'll get these Fraunhofer lines, these black lines, which will tell you, and depending on how wide they are and where they are, what elements there are. So while a star is basically made up of hydrogen and helium for most of its life, it will have trace parts of oxygen, carbon, and all that kind of stuff. So you can work out which stars formed from the same cluster. And also by doing, you can also do taking images of the cluster and say in January, come back, take it in June, take an image in June, and then you can use Pythagoras theorem to work out the parsec measurement, and you can kind of work out exactly whether they are part of the cluster. There is a European Space Agency mission called Gaia, and that is taking images of the entire universe so that we can see, and we're actually able to then it's over, I think, over about a month they take photos. So what it does is we can now actually see the slight movements of the star, and we can project where that star is moving to. And in the case of this cluster, it's actually coming towards us at 14 kilometers per second. So that's like getting here from the Perth Observatory to the CBD, which is about 35 k's away. That's probably about under 3 seconds or so. So it's moving fairly quickly. So but thankfully it's about 980 light years away. So we don't have to jump out of the way right away. But yeah, and it's actually older than the Butterfly Cluster. This is about 220 million years old.
Yeah, still the order of millions of years. So still very young in terms of in astronomical and stellar lifetimes. Yeah. I've also noticed, just like the Butterfly Cluster, it's also got most of the stars that we see in there are those hot blue type, blue-coloured stars, but there is a yellow star in there as well, which can indicate one that's
this one
starting.
right here.
It's declined to becoming a red giant and maybe a supernova in several million years, of course, but it's moving on to the next phase of its life.
Yeah.
Yeah.
So it was named after the Greek astronomer and mathematician Claudius Ptolemy in the 2nd century. And Ptolemy listed this cluster in his Almagest as the object number 567 and described it as a nebula following the sting of Scorpius in 130 AD. So nebula basically meant anything that, just this cloud. So you've got to remember that in the night sky, they didn't have telescopes back in the day, so they were just looking at the sky and just seeing what looked like clouds. And some of these clouds, like in the case of the Orion Nebula, were actually massive, big, giant dust clouds in space that were going to make stars. Other cloudiness objects were globular clusters, really big old stars. And then we've also had open star clusters, which are fairly big and made from all the stars that a nebula can make. And but because they're close, they look like a cloudiness. So yeah, and it's been looked at quite a lot. So they had French astronomer Nicolas Louis Delarcaille saw about 15 to 20 stars when he looked at it. Charles Messier, of course, made it his 7th entry in his first catalogue in 1764. And he described it as a star cluster more considerable than the preceding, which was M7, the Butterfly Cluster. To the naked eye, this cluster looked like a nebulosity. It is little distant from the preceding, placed between the bow of Sagittarius and the tail of Scorpius. And actually, it's one of those things that when you're trying to get a telescope to take particularly the Calvert telescope on a night sky tour, which unfortunately doesn't have a go-to feature, but does show stuff really nice. I think you've had this issue before, John, where you're trying to get the Calvert telescope on the butterfly cluster, but you're constantly finding the Ptolemy cluster because it's so big.
That's right. They're both very close together. Yes, it's but it again, it's like the butterfly cluster. It's also a very good. Well, obviously the ancients could see it, so it is a naked eye object, but also it's easy to find with binoculars. And as far as how large it appears in the sky, it's about 2 to 3 times the size of the full moon. So it's a fairly sizable object, and it should be especially in a dark side, it should be quite easy to spot.
And Kayla on Facebook is saying, hey guys, and thank you, Kayla, for sharing it with the Space Australia fan page as well. So it's great to see everyone tonight. And so before we go on to the Lagoon Nebula, I think what we'll do is we'll go and actually have a look at, because we're coming up to a very special season at the moment, and we've just entered it. So we're entering the Zodiacal Light season, and so I took holidays for a week, and thankfully the observatory didn't burn down, but I went down to Lake Clifton, and if you've never been to Lake Clifton, it is definitely a place to go to. It's about 20 minutes from Mandurah. So for people who aren't in West Australia and Perth, if you put in Google search for Perth and then you scroll down, you'll go past Rockingham and Mandurah, and then just about further a little bit down, you'll notice these big lakes, and these are lakes that were formed when the oceans were higher, and and then once the sea level came down, those lakes got trapped, and so they're fresh water. They're now filled with water from aquifers underneath the surface, and with the rain in winter, so they're quite high. The actual water level's quite high, and during winter, and then during summer, the actual thombolytes, which are the extinct metabolic life, and it's a really interesting sight. They look like big pumpkins, or these round-shaped or cone-shaped objects in the water. And so I was pretty impressed. I've never gone to a lake where it's been so still that as you can see in the images here, you can actually see the starlight on the lake as well. But you can actually notice right here that there's this massive this seam of like light pollution, and this light pollution isn't Perth, it isn't Mandurah, it isn't Bunbury. It's actually it's the Zodiacal Light. So this is light that has hit its backscattering of light off dust particles and ice particles that are spread out along the plane of the ecliptic. Now, the plane of the ecliptic is where the planets orbit. So it's quite the planets, apart from Pluto and the other dwarf planets, they do orbit in a kind of a nice disc shape. They're not absolutely perfect. They have different inclines in their orbit, but there is this nice disc of where they orbit, and it's not perfectly clean. That as we can see, we've got this dust particle. Have you ever seen this before, John?
I haven't up early enough to see them in the morning. No, I have seen it. It was quite a long time ago, but now that it is actually prime evening zodiac light season, being the spring equinox.
Yeah.
Yeah, this is a good time to see it. So I think I just have to make the effort.
Yeah, I think we would have seen it when we went up. You and I went up to Carnarvon in 2017 because the Geraldton Astronomical Society. Hello, Ken. They put on an astronomy night there, and we went out to the fish farm, which was in absolute complete darkness. And we would have seen it from there. So with September, it does favour the southern hemisphere because it's early evening that we get to see it. In March, it's better for the northern hemisphere because they'll get it in the evening. So if you are in the northern hemisphere, you can still see it. You're just going to have to get up before the sunrise. So it's always best to go out about an hour after sunset or before sunset if you're in the northern hemisphere at the moment, and try and find a dark place as possible. So again, with the government's whole thing of we can't go overseas, definitely go out and see some of these country towns and places in West Australia, because it is such a large state. And one thing I've found by doing these offsite events is just how beautiful West Australia is. You can go down to Albany and you get Old English country, and you go out to Kalgoorlie and on the way you go through the pastures as well, and you can get out to red dirt country, and even up north it's fantastic as well. And you'll get to see this, what looks to be like a slender pyramid of glow. It is pretty special, and you know you're in good sky conditions when you can see this as well. And we actually had, so that was Lake Clifton, and then this is actually this was last year when Jeff Scott, Ted Williamson, and I went up to the Mount Magnet Astro Rocks event as well, and that's going to be rescheduled for next year. So September, mid-September, around that time, that's when Astro Rocks Festival at Mount Magnet is going to arrive. And this was pretty special. That was a really good night. You can see the Milky Way with the Zodiacal Light as well. So yeah, it's something special. You can be freezing cold, and when you see this, you know it's worth it. All right, and so what we'll do is
just interesting additional thing. Another name for the zodiacal light. It's often referred to, well, if you see it before the sunrise, it's often known as false dawn.
Yes.
And false dusk, because you think, here comes the sun, but it's actually the zodiacal light.
Here comes the sun.
All together.
All right, so we're going to be going.
Thank you, Cat.
Pardon?
Yeah. So thank you, Cat Stephen.
Yeah. Actually, it was John Harrison who said, "Who comes the sun?" Isn't it? Yeah.
I get them all confused. Yeah, sorry, that's George Harrison. Yes.
Oh, it's okay. We'll forgive you on that one. You've got, and yeah, so this is exactly where we're looking for the Lagoon Nebula. So we're looking in and this is it right here, and this is the Lagoon Nebula. It's a really nice object to show on a night, as it helps if you can get away from this city to see this. But through our 30-inch, it looks pretty amazing as well. So it is a star nursery. So this is where baby stars form, and it's quite close to M20, which is called the Triford Nebula. I wish it was called the Tribble Nebula. For the Battlestar Galactica fans, and this was actually mentioned in the season 2 episode Home, and they identified the way to Earth using the Lagoon Nebula. So I've actually started rewatching the Battlestar Galactica episodes. They're fantastic. So they find Kobol, the planet where the humans are originally from, and they get to see all the constellations of the zodiac, and they have the big shot of the Lagoon Nebula, which looks amazing. So, John, how far away is this, and how big is it?
Well, again, it's one of these ones where it can be tricky to give it an exact distance, but they estimate it's about 4,000 to 6,000 light years away. Yeah. So when we're looking at through our telescope, the observatory, you're seeing it as it was possibly about 5,000 years ago, which is quite sobering. As far as dimensions goes, it depends how much you can actually see of it, because obviously the larger the telescope you use to view it, the more of it you can see. But based on measurements, its actual size it's sort of oval shaped, and its longer axis about 110 light years, and up at its shorter axis about 50 light years. So yeah, that's right. So it's fairly distant actually for many of the objects that we look at.
Yeah. And if people start talking about how, when someone asks you how a star is formed, and if someone starts going, well, there once was a mummy star and there was a daddy star as well, and they got together. Well, no, that doesn't actually quite happen for stars. This is where baby stars are formed. And so you can see here, we have a cloudiness of dust and gas, and you can actually see that we're actually having a lot of this is actually emissions nebula. So you're actually seeing hydrogen that has been ionized, and it's causing it to glow. So think of this as like a neon sign. You're seeing gas that is excited, and now that's glowing. And it doesn't take a lot for this gas and dust to start clumping together. The process starts off with basically clumps of gas and dust coming together through static electricity. So if you've got a balloon and you've ever rubbed it on your head, and as you pull it away, the hair sticks to it, or if you're an evil kid, sometimes like me, you'd scoot along and generate static electricity and come along to your sister or friend and zap them, or even your parents. And that is static electricity. So that starts the process of some of these dust particles. And when we talk about dust particles, essentially, if you haven't cleaned your desk or a bookcase for a long time, and you've got that dust and you swipe it across, that's really exactly what you're talking about. And mixing in with a little bit of hydrogen, a little bit of oxygen, a little bit of carbon, and as it starts forming, you get these clouds start collapsing, and you get this cocoon shape called a block globule. And in the middle of this cluster, in this cocoon, is a baby star forming, where you have material forming into the center point. And so that object's getting bigger. It gets stone, boulder size, mountain size. Then you get a planetoid, and it's getting bigger and bigger. And as it's getting bigger, it's growing in its capacity for gravity. So it's pulling in a lot more material. It's also getting hotter because you've got more stuff falling onto it. And once it gets hot enough for nuclear fusion, where you can fuse two hydrogen atoms into a helium atom, the star ignites, blows away a lot of that material, and what's left over is a planetary disk where planets are forming as well. And so this is the process of how stars form. And this so we've seen some star clusters before. We're seeing what those star clusters come from. Those star clusters would have once been nebulas, and this process, it does take, in terms of universe, does take quite a short amount of period. It only takes a couple of 100 million years for all those stars to form, and it's one of those amazing things. Unfortunately, we don't have the lifespan to see this or experience time sped up so that we can see this over a large period of time. But there are some fantastic modelling that people have done over the years, really thankful that with this photo at least that we have our Nikon D810A, which is the Nikon D810 supercharged for astrophotography, so that we can at least see some of this hydrogen alpha stuff as well.
This is right. This is one of the frustrating things with, I guess, showing nebulas on the night sky tours, is that people have probably seen pictures of them online or in books and seen these wonderful colours. And when they look through it in our telescope, they certainly see it. And the Lagoon Nebula looks wonderful. Especially with that big eyepiece, it feels like you're swimming in it. And it almost looks three-dimensional, but it just comes out as a grey-green colour usually.
Yeah, and even if we were there, right there next to it, it would still look that bluish teal grey colour as well, which is the sad thing. The reason we've got this colour coming out of it is because this image is taken. It's an image taken about 10 to 30 seconds, and so we're seeing a lot of this colour because the light is just so weak. And if you've ever seen Star Trek, no, you can't. You actually can't hide a spacecraft in one of these nebulas. These nebulas are so light that even in the place where the International Space Station orbits, which is about 408 kilometers above us, has more particles than actually in some of these nebulas. So it is quite amazing as well. Amazing that you can actually get stars from something which has so little particles in it per square kilometer. And so you can actually, it's nice to see, John. You can actually see this dark lane through here. That's they call the reason they call it the Lagoon Nebula is because they when you see, this is the sandbar through here, and then on either side of the sandbar you have two lagoons. That's what they can see as well. So yeah, but strangely enough, John, is there any mythology associated with this cloud?
Actually, not that I'm aware of.
No, it's quite strange. There's no real mythology associated with this, and they would have easily been able to see it back in the day as well. This star cluster here, this is actually called NGC, or New General Catalogue 6530, and so they're only a few million years old as well. So
this is another one. It actually is in a good sight. This is also visible vaguely to the naked eye, and obviously through binoculars you can see some structure to it as well. Again, it's a rather visually, it's a large object. Again, it's about 2 or 3 times the size of the full moon. So size-wise, it's quite visible. Obviously, brightness-wise, it's fairly dull, but under good seeing, it is quite possible to see it. And obviously, through binoculars, it's a good target through the binoculars as well.
Yeah. All right. So the next one we'll go to is we're actually going to be showing it. We'll have to go back a couple of months because it's now getting below the horizon. But I didn't actually get to show it to people later on, earlier on. So we'll go a little bit. Okay, so over here we have Virgo, and the cluster, and right through here they've noticed, it's been noticed for quite a while that there are quite a lot of galaxies. Right here, you can see a whole spate of galaxies right here, and over the period of time, they realized that actually, once they realized that galaxies aren't nebula in our galaxy, but they're actually their own galaxies further out. They realized actually that we have superclusters of galaxies, And so this shot right here, these galaxies here are actually part of what's called the Virgo Supercluster, or what's also called the Local Supercluster. And it's a mass concentration of galaxies. And they're talking about 100 galaxies are grouped in this cluster. And it's located in a diameter of about 110 million light years across. This one right here is called M86. And so that's in the center of the actual Virgo supercluster. It's actually one of 10 million superclusters that I've seen in the observable universe. So when you think of the universe, as we go out further and further and further away, it looks like it's actually it looks like a web, a massive big spider's web with lines of galaxies and connecting big circles of superclusters or spheres of superclusters. And in 2014, there was a study that actually showed that the Virgo supercluster is only a lobe of an even greater supercluster called Lenticular. And we've always heard of this term, the Great Attractor, where it appeared that all the galaxies in our local area were moving to this central point. And what the Great Attractor is this giant supercluster called Lenticular. And so the very first time we actually we started suspecting this, it came out from the samples that William and John Herschel had seen in 1863. And it was known that there was a marked excess of nebula in that field. And then it ended up being in the 50s as well. And it was actually a French astronomer called Gerald Henry de Vauquelin who actually first argued that this excess represented a large galaxy-like structure, coining them a local super galaxy in 1953. And which he then changed to local supercluster in 1958. But there was a bit of debate, wasn't there, John, about this in the 60s and 70s as to whether it was a local supercluster or if it was just a structure or a chance alignment of galaxies.
That's right. Yes. Like many clusters, like some of the things we look at through our telescopes at night, sometimes a fortuitous lineup of objects makes them look like they're together. It's not till you can do distance measurements or motion measurements that you can work out whether they are actually part of the same system or whether they're separated. So I'm not exactly sure how they came. I believe it's a series of redshift studies.
Yeah.
So measuring how fast they were receding, and to see if they're all if they obeyed Hubble's law, I think. Correct me if I'm wrong, but they used that sort of technique to measure that they were all in the similar area.
Yeah, those surveys were done in the late 70s and 80s, and they convincingly showed that the flattened concentration of the galaxies along the super galactic plane as well. So, as you can see.
Just looking at it, the cluster, even though there are all these galaxies that are kind of part of a group, there is quite a variety of galaxy shapes. There's a whole range of galaxy shapes, so spiral, barred spiral, elliptical, and so on.
Because you can and also the angle that they show to us as well, so you can see. So these are the two elliptical galaxies in view, and there's actually in the image I had to because it's 16 by 9, I missed out on it. But there's also one up here as well, which is an elliptical. But we can see these spiral galaxies at different angles as well.
exactly. I'm just looking at in the center there. So you've got those spiral galaxies, but in the middle, well, pretty much in the middle, which I believe is M84,
Yep.
and then off to the left a bit, if I'm looking at the right one, there's another sort of just looks like a solid white ball. I think that's M86.
Yeah, that's it. Yeah.
Yeah, and these are about 50 million light years away, from what I understand. And the type of galaxies they are. So around it looks like you have spiral galaxies, which is what a lot of people think of. The first shape that people think of, because they think our Milky Way is that shape. But these ones they're actually called lenticular galaxies. I thought, well, lenticular, it's one of those fancy words they tend to use, but lenticular means shaped like a lens. So, and actually the word lens comes from the Latin word for lentil. So, I'm not joking. So that's lentil-shaped galaxies.
No. And yeah, it's always nice to see especially when you can do astrophotography and you get to see these nebulas, these galaxies come out from their hiding places because the light is so weak. But that's one interesting thing. As you say, 50 million light years away from us, guys. When we look through telescopes, we're looking back in time. So when you're seeing objects as they were 50 million years ago, and so if you were in a star around that one of these galaxies and looking back at our galaxy, you'd be seeing our galaxy as it is 50 million years ago, because that light has taken all those years to get to into our eyeballs. So a light particle travels nearly about 9.5 trillion kilometers a year, and so that's a light year. So that light has traveled so long, and the thing, what we actually find is that as we go further and further and further into the observable universe, that light changes from visible light into radio and also microwave light, of the part of the light spectrum. And so that's where you need radio telescopes to see almost to the very beginning of the universe as well. So there's frequency change as that light makes that large journey as well. And we've even been able to change, so we've saved missions like Cassini went to Saturn. It realized that it was listening to the wrong frequency. That's the Huygens probe that was going to land on Saturn's moon Titan, and so they had to change which flyby instead of the first flyby to the second flyby, so to the third flyby of Titan, to release the Huygens probe, because after the 20-day journey to Titan, where Cassini was, meant that there was enough change in the frequency that Huygens was transmitting on that Cassini could listen. That signal would then change over that journey and would be the right frequency for Cassini to listen to. So it's quite amazing. Light particles are just fantastic about it as well. The other thing with this supercluster is that it's made up of two components. There's a flattened disk which contains about 2/3 of the supercluster's luminous galaxies. So we're kind of looking in that area there, and then there's a halo that exists around this disk that has the remaining 1/3 as well. So it's one of those amazing things. We're gonna give up on it in our night sky because it's getting too low to the horizon. But give it a couple of months and it will come back. And if you're talking about weight, how much this supercluster weighs, there is approximately 7,000 times that of the local group of galaxies, or about 100 billion times that of the Milky Way in terms of mass. So it's quite amazing. And it's actually represents a typical poor supercluster that we've seen, and a rather small size. So there are much bigger superclusters out there with much more with much more galaxies. This Virgo supercluster actually has quite a lot of galaxies in the center. There's that center of galaxies is quite rich, but once you get out to the suburbs and to the ends of the supercluster, it does actually have quite a poor number of superclusters. So it's one of these things that you think, oh well, it looks so amazing, but when you go out with Hubble and eventually hopefully with James Webb, you'll notice that there are massive big superclusters with so many more galaxies as well. So, but thank you.
Not about thinking too much, because I'm feeling quite small and insignificant now.
That blue dot there. But yeah. All right, guys. Well, thank you very much for putting up with the technical issues at the very beginning. Thankfully, we've got them sorted out, and we'll do some more. We'll probably do some testing during the week just to see whether we can actually work out those issues. And but thanks very much, guys. If you do like this video, these live streams, please subscribe to the channel, and also like the video. That would be fantastic. And also tell your friends. And now that we're doing these on Facebook and also Twitch and Periscope as well, we're going to get out to more people so that everyone can enjoy the southern sky. So the next one of these will be in 2 weeks' time. So Roger and I will be out. For the Facebook people, Roger is another volunteer who helps me do these live streams. And so we're going to be going out to the northwest. The northwest of West Australia, and we're going to be going to Gascoyne Junction for next weekend, and then we'll come back, and on the 23rd we'll have our next live stream. And so yeah, and guys, also if you do come to one of our events and you've heard like our workshops or our night sky tours here, we are in all of the little bookings, we ask where you've heard. If you let us know, in the little options there is these the virtual star party. So click on there just so we know that you guys do also watch the video, and that we are getting people coming to the observatory because of these live streams. That would be fantastic as well. Thanks, guys, and hopefully we'll see you in 2 weeks. Stay safe, and we'll see you at either the Kalbarri workshop or in the Gascoyne Junction, or even the spring equinox. It's morning tea as well, or on a night sky tour.
Our night sky tours looking, they're all full up. They're all full, or are they still?
We've got spots still. We've got 2 nights left in October, so you lock West Australians down for 3 months, and once those 3 months are up, they are certainly raring to go. So thanks.
There are some fabulous targets at the moment, especially Jupiter and Saturn are great viewing at the moment. So has a great time to come up,
and Mars is coming up in October as well. So
that's right, a good close one. It won't be this. It'll take about another 5-6 years, I think, before it's this visible again. Every 2 years it's worth looking at Mars. All the other times it just looks a red dot. Well, the opposition that we go, this opposition will be nice and close. So Mars got a very eccentric orbit or elliptical orbit, and Earth's is nearly round, and so when our closest approach can vary quite a lot, and this one's going